So this is section 5.1, composite functions. And in composite functions, what we're doing is we are going to plug in a number or a function into another function. And what you want to do is you want to start at the end and you want to work your way back. So for the first one here, if we're going to do, so for A, we have f of g of 4. So, like I said, you start at the end and you work your way back. So we have g of 4. So you're going to plug in 4 to your g of x function. So we have 2 times 4 minus 5. And it's super important to get this correct because that will affect your entire answer. So 2 times 4 is 8. 8 minus 5 is 3. Then you take the 3 and, like I said, you work your way back and you plug into the f function. So f of 3, we have 3 times 3 squared plus 1. So 9 times 3 is 27. 27 plus 1 is 28. So f of g of 4 is 28. All right, so for B, we have g of f of 2. So we're going to take 2 and plug it into our f function. And we have 3 times 2 squared plus 1. So 2 squared is 4. 4 times 3 is 12. 12 plus 1 is 13. And then we're going to take 13 and plug it into g. So we have 2 times 13 minus 5. So that's going to be 26. 26 minus 5 is 21. So g of f of 2 equals 21. All right, then we have for C, f of f of 1. So we take 1 and plug it into our f function. We have 3 times 1 squared plus 1. So 1 squared is 1. 1 times 3 is 3. 3 plus 1 is 4. And we're going to plug 4, and we're going to plug it into the f function. We're going to use the f function again. So 3 times 4 squared plus 1. So we have 4 squared is 16, and 16 times 3 plus 1 gives us 49. So f of 1 equals 49. And then for D, we have g of 0. So we do g of 0, which is going to be 2 times 0 minus 5. So that would be negative 5. And then we do g of negative 5, which will be 2 times negative 5 minus 5. So negative 10 minus 5 will be negative 15. So g of 0 equals negative 15. All right, so for B, we just have 2 different functions. We'll do the same thing here. So f of g of 4. So we'll start with g of 4. So that would be 3 times 4, which is 12. And now we'll do f of 12. So 12 plus 1, we just get the square root of 13. So f of g of 4 equals the square root of 13. For B, we have g of f of 2, so we do f of 2, which will be square root of 2 plus 1, which is square root of 3. And then we do g of square root of 3. So that's just 3 times the square root of 3, and that's it. We can't simplify that anymore. So g of f of 2 is 3 square root of 3. For C, f of 1. So we have the square root of 1 plus 1 is going to be the square root of 2. And now we do f of the square root of 2. So we have the square root of the square root of 2 plus 1. And that's our answer for that one. Looks kind of crazy, but that's what our answer is. So f of 1 is square root of 2 plus 1. And for D, we have g of 0. So we start with g of 0, which is just 3 times 0, which is 0. So we plug in 0 again, and we get the same thing again. So g of 0 equals 0. Okay. So for example 2, these are going to be plug-in functions into functions, and we're also going to state the domain. So we're going to state the domain of each function before we start. So the domain of this function of f of x is going to be negative infinity to infinity. Whoops. And the domain of our g function is also going to be negative infinity to infinity because we have no restrictions. So remember, we have to worry about restrictions when we have fractions, radicals, or radicals in the denominator. So when we do A, we have f of g of x. So what we're going to do is we're going to take our g of x function and plug it into f of x. So I'm going to take this one, and it's going to go into x here. Now I'm going to erase this in a little bit. You may not want to mark that on your paper because I can erase mine a little bit more easily than yours. But I'm going to take the g, like I said, and plug it into x. And I like to put parentheses around it. So I have that x squared plus 4 and then plus 1. And I'm going to simplify this. So that's just going to be x squared plus 5. So f of g of x is that. Now, no fractions, no radicals. So my domain is negative infinity to infinity. There's no restrictions. There's nothing x can't be. I can plug anything in for x. So my domain is negative infinity to infinity. So for B, I'm doing g of f of x, which means I'm doing the reverse here. I'm taking x plus 1 and I'm plugging it in here. So I'm taking x plus 1 squared plus 4, which means I need to FOIL this out. Okay, so x times x is x squared, x times 1 is x, 1 times x is x, so I have 2 of those x's, so 2x, 1 times 1 is 1, and then I have my plus 4. So 1 plus 4, I have like terms, so that's going to be a 5. So g of f of x equals x squared plus 2x plus 5. Again, no fractions or radicals, so my domain is negative infinity to infinity. All right, when I look at C, I'm doing f of x. So I'm plugging f of x into itself. So I'm taking x plus 1 and plugging it into x plus 1. So I have x plus 1, plugging it, so that's like where that x was, plus 1. Okay, so here are my like terms, so that's going to be x plus 2. So that was pretty simple. And again, no fractions or radicals, so my domain is negative infinity to infinity. And then for D, I'm doing g of x, so I'm plugging g into itself. So I have the x squared plus 4, and that's being squared, plus 4. Okay, so that's where that x squared was going right there. So if I simplify this, I am writing this out twice, and then plus 4. So I need to square that. I need to FOIL that out. So x squared times x squared is x to the 4th. X squared times 4 is 4x squared. And then 4 times x squared is 4x squared. So there's 2 of those. There's 2 4x squareds, which gives me 8x squared. And then 4 times 4 is 16, and then plus 4. So there's my like terms. I have x to the 4th plus 8x squared plus 20. So here is my g of x. And then my domain, again, is negative infinity to infinity. Okay, so on this one, my restrictions, I start off with my restrictions like x, negative 3. So like it can't be negative 3. So my domain is negative infinity to negative 3. union negative 3 to infinity. And here, I don't want it to be 1. My restrictions would be 1. So my domain would be negative infinity to 1, union 1 to infinity. Okay, so for A, I'm going to start off with, what was A? F of G of X. So again, I'm taking G and I'm plugging it into F of X. So I have 1 over 2 over X minus 1 plus 3. Now, this is a complex fraction, so what I want to do is I look at this denominator here, and I'm going to multiply the top and the bottom by X minus 1 to get rid of that. So my top is going to become X minus 1. Now, this I need to multiply the X minus 1 times this part and this part. So 2 over X minus 1 times X minus 1, that fraction clears out. That's the whole point of doing this. So that part just becomes a 2. 3 times X minus 1, I'm distributing that 3, so that will be 3X minus 3. And then what I need to do here is I'm going to simplify my denominator. So I get 3X, and then 2 minus 3 is negative 1. So this is my composite function. Now I need to do my domain. So I'm looking at all of my denominators, which is here and here. So I have the X equals 1 for that one. And for this one, if I did like 3 equals 1, if I set that equal to 0 and then divide by 3, so X equals 1/3. So when I write my denominator, negative infinity to 1/3 union 1/3 to 1 union 1 to infinity. Because I have to talk about all of my restrictions. Where can it not be? What's going to make it 0 for the bottom of the fractions? So for B, G, I think it was G of F. Yeah. So for G, or for B, G of F of X. Okay, so I'm going to plug in F into G of X. So that's going to be 2 over 1 over X plus 3 minus 1. So again, a complex fraction, I want to multiply. All right, so that is going to give me on top, if I distribute the X plus 3, 2X plus 6. On the bottom, so I multiply it by that one and this one. So when I do 1 over X plus 3 times X plus 3, the X plus 3's go away, and I'm left with 1. Negative 1 times X plus 3 is going to be negative X minus 3. So I get 2X plus 6 on top. On the bottom, I get negative X minus 2. So there's my composite function. Now I'll look anywhere I have a fraction, here and here. So I have a negative 3 as a restriction. Now, here, if I set that equal to 2, I need to divide by negative 1. So my restriction is actually negative 2 right there. So I got negative 3 and negative 2 is my restriction. So I do negative infinity to negative 3, union negative 3 to negative 2, union negative 2 to infinity. All right, for C, I think we were doing F of F. Okay, so that one, let's see here. So I'm plugging F into itself. So I have 1 over X plus 3 plus 3. So I'm multiplying by X plus 3. Okay, so on top, I get X plus 3. On the bottom, remember you multiply both of these. So that just gives me 1 because the X plus 3's cancel. And then I will get 3X plus 9. So I have X plus 3 on top. And then on the bottom, I have 3X plus 10. So here's my composite function. I'll look at my fractions to find my restrictions. I'm looking at my denominators. So my restriction is X equals negative 3. And then I'll have 3x equals negative 10. I divide by 3, so x equals negative 10 thirds. So my domain is negative infinity to negative 10 thirds, union negative 10 thirds to negative 3, union negative 3 to infinity. All right, and then for D, I'm doing g of g of x. So let me see what my g function was. So I have 2 over x minus 1 minus 1. Okay, so simplify this. I need to multiply by that x minus 1 over x minus 1. So that gives me 2x minus 2 over, and remember I multiply both of these. So the x minus 1's cancel. I get a 2. Negative 1 times x minus 1 would be negative x plus 1. All right, so on this one, that should be an x plus 3 for my function, my composite function, which means x is going to equal 3 for the restriction of my domain. So then my domain would be negative infinity to 1, 1 to 3, and then 3 to infinity.